Right, in this mini lecture, we're going to look at statistics and specifically sampling, frequency distributions, and graphs. So what we'll try to do here is quickly describe a population that's to be analyzed. Then we'll select an appropriate sampling technique, and then we'll also show how to organize and present data. So first we should go over some basic definitions. First is statistics. What is it? Well, it's the method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. So the methodology is divided into two main areas. So here are the two main areas. We have the first area, which is called descriptive statistics. This is where we do the collecting, the organizing, summarizing, and presenting the data. So this will be the first part of any statistics course. Right, and then comes the inferential statistics. It's usually the second half of the course, second half of the semester in a statistics course. Here you're making generalizations about and drawing conclusions from the data that you've collected. Okay, so we need to first understand the idea of populations and samples. What is a population? This will come up a lot. It's basically the set containing all the people or objects whose properties are to be described and analyzed by the data collector. And then there is the sample, which is the subset or subgroup of the population. So let's say I was going to give a survey out to some college. We'll call it college. We'll call it college, RB College. So I wanted to give a survey about student satisfaction in, maybe they have some nice cafeteria that they just built. So the population would be all of the students at RB College, right? I could possibly try to give out a survey to all of the students. Maybe they have 10,000 students. It's a really large college university. It's probably not practical to give out the survey to all 10,000 students. So this is my population. So what I would do is find me a sample, which is the subset or subgroup of the population. So maybe I'll take a subset, which could be anything that represents the entire population. So I'll take, let's say, 10 classes, and they could be, let's say, 10 math classes, 10 random math classes. So this would be my sample. Take all the students in the 10 math classes. That's my sample because they're a representation, they're a subset of the entire population. And now that's more practical, right? Giving a survey out to all of the students in 10 different class sections. And we're talking about a representative sample. So this is a sample that exhibits the characteristics typical of those possessed by the target population. So my 10 classes sections, that would be a representative sample of the population because they share all the same characteristics of the entire school population. Let's look at a quick example. So our example says a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So let's say we were asked here to describe the population. Describe the population. So take your time and reread through it if you need to. And now understand the population. The population definition, remember, was all the people or objects whose properties are to be described and analyzed by the data collector. Okay, so the population here is going to be the set of all citizens, of the city. So the set of all citizens of the city. So that would be the population. All right, so let's look at another scenario. Let's say one of the hotel owners suggests that obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night, right? So that's his suggestion. He says, get a sample, because you can't do the entire population, obviously. You can't survey all the citizens in a city. So one of the owners is saying to get a sample, and you can do that, he says, by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. And each person will be asked to express his or her opinion on casino gambling. So does that seem like a good idea? Think about it. Well, questioning people at 6 of the city's largest nightclubs, that's not a good idea. The nightclub subset is probably more likely to have a positive attitude toward casino gambling than the population of all the city residents, right? Okay, so now we move into random sampling. So what is a random sample? So it is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. Okay, so there's a methodology involved. So the methodology is as such. The first thing you do is identify each element in the population. Then you assign numbers to each element in the population. Next, randomly select numbers, and then assign the elements in the population who have those numbers to the sample set. Okay, looking at another example. So we return to the hotel owners in the large city who are interested in how the city's citizens, how they feel about casino gambling. So we're asking now, which of the following would be the most appropriate way to select a random sample? How about randomly survey people who live in the oceanfront condominiums in the city, in the oceanfront condominiums? Well, a lot of hotels lie along the oceanfront, and these people, they might object to the increased traffic and the noise which may result. So it doesn't give each citizen of the city an equal chance at giving their say on the survey. All right, how about surveying the first 200 people whose names appear in the city's telephone directory? This still, if you look at it, right, it still doesn't give each citizen in the city an equal opportunity to participate in the survey. And how about we randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods? That's more like it, right? So we'll say yes to this one. We'll say yes to this one because this gives each citizen in the city an equal chance at getting surveyed. All right, now let's take a look at our next example. Our next example says to construct a frequency distribution. So this is important in statistics. to start learning how to construct frequency distributions for the data of the age of maximum yearly growth for 35 boys. All right, so here is the raw data. It's just presented to us here from 12 all the way down here to 14. So it's just raw data given to us. So these are the data for the age of maximum yearly growth for 35 boys, and they're telling us to construct a frequency distribution. All right, so what I'm going to do, I'm just going to place it to the right of the data. So I'll say age of maximum growth. You can go right here. Age of maximum growth. Okay. And then next to it we can have the number of boys. The number of boys right here. And the number of boys is actually our frequency. It's going to be what's known as our frequency. So I'll put that in parentheses. Okay, so we look at it and we're looking at the age of maximum growth. The age of maximum growth. So we'll put it in order. These values that are to the left, we'll put them in order. So the age of maximum growth, the youngest age I see is 10. That's the youngest age that I see. So I'll put that down here under age of maximum growth. So I see 10 as the youngest age in that data set. I also see some 11s, some 12s, 13s, 14s, 15s, 16s, 17s, and 17 and 18. I see a 17 in the data set and an 18. So all I did was look in the data set and just look at all the ages that are represented, and then I wrote them down from 10 through 18. Now what we'll do is go back into the data set and identify their frequency, so the number of times that it occurs. So we're 10. I only see it occurring once, so I put a 1 right there. 11-year-olds, I see it there and there twice. And just do the same thing for all of the other ages. 12 occurs 5 times. 13 occurs 7 times. 14 occurs 9 times. 15 occurs 6 times. And then 16 occurs 3 times. 3 times. And 17 occurs once, and 18 occurs once. So then there's a total. We'll call the total our n. So n is equal to, just adding all of these frequencies up, looks to be 35. 35. So let's look at some of the conclusions that we can draw from this example. So this frequency distribution that we just created tells us that one subject had a maximum growth at age 10, right there, and then 2 at age 11, 5 at age 12, 7 at age 13, and so on. And then the maximum growth for most of the subjects occurred between the ages of 12 and 15, right? Between 12 and 15, that's when the maximum growth occurred. And then 9 boys experienced maximum growth at age 14. At age 14. And more than at any other age within the sample, looks like. The sum of the frequencies, which we said was 35, that's equal to the original number of data items. So we said that there were 35 boys and 35 data items there. So that's why we get the 35 that is that same value. So then there's a trend that we can see, right? The trend in looking at this, shown by this frequency distribution, indicates that the number of boys who attain their maximum yearly growth at a given age increases up until the age of 14, right? It increases up until the age of 14 because we see 1, 2, 5, 7, 9, and 1, 2, 5, 7, and 9, right? This is from age 10 to 14. So that increases up until the age of 14. And then after the age of 14, it begins to decrease. It decreases after that. So that's a trend that we can see based on the frequency distribution. So that's one of the good things about constructing one. Whereas just by looking at this raw data over here to the left, we would not have seen that. That trend wouldn't have been as evident in the original format of the data. Okay, so now we move on to our next example. Our example here says, here are the statistics test scores for a class of 40 students. So it's giving to you as the raw data. We're told to go ahead and group the frequencies into classes this time. So group them into classes. So group them into classes that are meaningful for the data. So since letter grades are given based on 10-point ranges, they're telling us, which is good, they're telling us use these classes: 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99, right? They're telling you, let's use those classes. So what I'm going to do is create a distribution. So I'll have class, and then the frequency. The class, and then the frequency. So they're telling us to use 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. All right, so all we do now is just go back into the data set and say, okay, how many of these fall into the first class of 40 to 49? So I'm looking for any numbers between 40 and 49. So you just have to take your time and go through each row or each column, however you want to do it. 47 is between 40 and 49. What other number there? 45 between 40 and 49. And 43. And look at the last row. Nope, nothing there. So the frequency there is 3. And now you do the same thing for 50 to 59. So I'll go through each row. 57 is between 50 and 59. 54 is between 50 and 59. Let's see what else. 56 is between 50 and 59. 57, 50, and 59. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's a frequency of 6. So I think you get the picture. So you do that for the rest of those. So what I would do if I were you all, I would pause and go ahead and work through that and do it for the rest of the classes. And then see if it matches up with my numbers. So for 60 to 69, I get 6. 70 to 79, I get 11. And 80 to 89, I get 9. And then 90 to 99, I get 5. So then there's the total, which is the n value. We call our n value, and that's equal to 40. After I add them all up, 40. So that's the sum of the frequencies, and it's the number of data items. Okay, so we work through that given the classes in this example. All right, and next we want to take a look at stem and leaf plots, stem and leaf plots. Okay, so we're going to use the data below for a stem and leaf plot. Okay, so the data below is given. We don't know what it is, where it's from. They're just giving us some raw data. That's fine. So what we're going to do is create a stem and leaf plot. So that's another way to represent and show the data. So we have a stem, and then we have leaves. So the stems consist of the numbers. We have numbers in ones and tens, right? Those are the place values for these numbers, ones and tens. So the stems are the numbers that are in the tens place. So looking through all of this data, all the numbers, looks like the smallest number is like 47. And then looking through this, the largest number is 94. Well, actually, the smallest number is 43, right? And the largest number is 94. So I see numbers in their 40s, and I'm just still looking through all this data. I see numbers in their 40s, 50s, 60s, 70s, 80s, and 90s. So that's going to be my stem then, because I see numbers in their 40s, 50s, I see some 50s, I see some 60s, some 70s, some 80s, and some 90s. Okay, so since that's the case, those are my stems. The numbers in the tens places are my stems. And now I look for the leaves. Those would be the numbers in the ones place. The numbers in the ones place. So I'm looking at for 40s now, starting for the 40s. So I see a 47. So a 7 can go there. And I'm just going to go through each row looking for my 40s. In this fourth row, I see a 45, so put a 5 there as another leaf. Then next to it, I see a 43, so I put a 3 there. So you see how the stem, along with the leaf, creates the numbers. So that 47 is right here, 45, and 43. They're all represented with my stem and the 3 leaves of 7, 5, and 3. So the 4 is the tens place, the 7, the 5, and the 3 are 3 different values to represent 3 different numbers for the ones places. So 47, 45, and 43. Okay, so now I'll go back and I'll look for any number that is in the 50s. So first row, I see a 57, right? So 5 is the stem, 7 is the leaf. Keep going to the next row, I see a 54, so I put a 4 in the leaf. And I keep going, I see a 56, so a 6 goes in the leaf. I see a 57 on my last row, first number in the last row, so a 7 goes there. I see a 50, so a 0 goes there. And a 59, so a 9 goes there. So that tells me all the numbers in the 50s, 57, 54, 56, 57, 50, and 59. All right, so the next thing you should do is pause the video and you yourself go ahead and create the leaves for the 60s, the 70s, the 80s, and the 90s. And then see if it matches up with my answers. Okay, so now I've added the rest of my leaves as I went through all the data and for the 60s, 70s, 80s, and 90s. So again, the stems are the tens digits, and then the leaves are the unit digits, which for us are the ones places. So this is how we have created a stem and leaf plot from the raw data that was given.